All right, here we go. We're talking about 4.7 Math 1. We're going to talk about some of these different things. We're on page 229, mainly dealing with perpendicular lines. Hopefully you've already got the box copied down on the top of page 229, so we can talk about each one. The first one there says the distance from a point to a line is the length of the perpendicular segment to the point of the line. Okay? What I want you to know right now, we may do more on this later, but what I want you to know now, okay, is that if I draw a line and I have a point, okay, the shortest distance between that point and that line has to be a perpendicular line. Okay? Any other line that was out here like this or like this would not be perpendicular. If it was any other angle, it wouldn't be the shortest line. Okay? So the shortest distance between a point and a line is always going to be perpendicular. Okay? So an example question, I might say, is AB the shortest distance? And if you don't see that box there, you wouldn't be able to say yes. Okay? But if I tell you that is AB the shortest distance now, and you see that box, you would be able to say yes. Okay? The shortest distance between a point and a line is a perpendicular line, meaning you need to see that point right there. This is especially important when later on we do circles. When we talk about things being equal distant from the center of the circle, you have to see that box in order to know that it's the shortest distance. Yes?
So if we don't see that box, do we say that you don't know?
You don't know enough, or the answer would be no. You cannot definitively say that from A to B that's the shortest distance. Okay? Later on, we're actually going to find the distance. Okay? Similar to the distance formula that you did on last test, but it'll be a little different. I'm not ready to teach that today. I just want you to know that it's perpendicular. Okay? Good question. Anybody else have a question? Okay? Moving right along, read the next line for me, BJ. Nice and loud. Transversal.
A transversal is a line that intersects two or more coplanar lines at different points.
Okay? So if I have two lines, right, not necessarily parallel, okay, they could be parallel, okay, and I cut those two lines with a single line, that line is called a transversal. And luckily, we label it with a lowercase t. A transversal cuts two other lines. Okay? If I wanted to make these lines parallel, what symbol or notation would I put on? Say again? Upside down T, no. That's not upside down. Upside down T is perpendicular. Okay? So what is the...
Two lines, like a levee.
It looks like a dart. You're right. This is the symbol for parallel, but when I'm drawing it, I call them darts back from drafting. But when you add those darts on there, then that means that those two lines are parallel. So you have parallel lines and you have a transversal. Do you remember from 8th grade, right, that this angle and this angle are congruent? By what reason? Do you remember the reason? I know you're digging back in those files.
Yeah,
right?
it looks familiar.
Those are called corresponding angles, right? Corresponding angles. How about this angle and this angle? Are those congruent?
Yeah.
Alternate interior angles. Very good. I'm not testing you over any of this. I'm just kind of refreshing you. How about this angle and this angle?
Alternate exterior.
See, you do remember all that middle school stuff, right? You just need a little refresher. So transversal, right? We have to talk about it to understand some of these other theorems. But a transversal is a line that cuts two other lines. Okay? Questions? Anybody have a question about a transversal? Yes, ma'am.
The sign for parallel is two lines that have a little arrow.
Let's say that this was L and this was R. If I wanted to say it, I would say L is parallel to R. Okay? Is that what you were asking? Okay. Anybody else? Okay, good question. All right. Hodges, read out Theorem 4.7 for me nice and loud.
If two lines intersect to form a linear pair of congruent angles, then the lines are perpendicular.
All right. If two lines intersect to form a linear pair, so here we got a linear pair, here and here. We talked about that in depth at the beginning of the period. They are also congruent. So we have an angle here and an angle here that form a linear pair, and it says they are congruent. They form a linear pair of congruent angles. Then, what do I know? What do these two things have to be if they're equal and they add up to 180?
90 degrees.
They got to be 90 and 90. So what that's saying is, if they are congruent, then they are perpendicular. Okay, the lines are perpendicular. That means that this is 90 and this is 90. They might just say, find x. Okay, if I tell you that that's congruent to that and it makes a straight line, x has got to be what?
90 degrees.
90 degrees. Okay? Guys, if y'all walk in today without any instruction, and I put that problem up there, most of you would be able to get that, right? It's intuitive. If those two things are equal and they equal 180, then one of them's got to be 90 and the other one's got to be 90. Okay? These theorems are pretty straightforward. Any questions before we move on? All right, Anna, read out Theorem 4.8.
Theorem 4.8. If two lines are perpendicular, then they intersect to form four right angles.
All right, what that's saying is, if two lines are perpendicular, meaning I do that, right, then how many right angles does it create? It creates 4 right angles. And so you could do the box all the way around. Okay? So a problem, it might say there's x, there's a right angle, those two lines are perpendicular, find x, find y, find z. They might ask you all three of them. Right? X, y, and z all equal what? 90 degrees. Okay? 90 degrees. Now it might not always be that easy. Right? They may split this angle, right, into x and y. What do you know about x and y now?
They both equal.
Right. You know that x plus y has got to equal 90 degrees. You know it by this theorem and you know it by another theorem. What's the other theorem? What's true about these two and that one? They're vertical. They're not adjacent. They're vertical, right? The big angle, x plus y, and that one are vertical, so they got to be congruent. Question?
Are we not gonna write these?
You need to know the information in the theorem. Okay, I won't ask you which theorem, I won't ask you the name or anything like that. Okay, good question. All right, Bella, read out the next theorem for me. We're moving kind of fast, but these are pretty easy. If you have a question, raise your hand.
Theorem 4.9. If two sides are two adjacent acute angles.
All right, stop right there. Oh, keep the next two words are what?
Perpendicular.
All right, let's stop right there. There's the hypothesis. Read it one more time.
If two sides are two adjacent acute angles are perpendicular.
All right. There are 3 words. Adjacent are these two angles. I'll put numbers there. Are angle 1 and angle 2 adjacent?
Yes.
Yes, they are. Are angle 1 and angle 2 acute? Because it says adjacent acute angles. Are angle 1 and angle 2 acute?
Yes.
What's the definition of acute?
Less than 90 degrees.
Less than 90 degrees. So angle 1 and angle 2 are adjacent. Angle 1 and angle 2 are acute. Then the last constraint on the definition is that angle 1 and angle 2 are what?
Complementary.
Wait, did I mess up? If two sides, okay. If two sides of two adjacent angles are perpendicular, that means this side and this side. Are those two sides perpendicular? Yes, they are. All right, then what's the conclusion? Then they are what?
Complementary.
Complementary. What's the definition of complementary? And they add up to 90 degrees. Okay? And like I said, guys, if I asked you, if I came in here and said, hey, find x, everybody in here probably, when you walked in the door without any explanation, would be able to tell me that x equals what?
60.
60. Okay, x equals 60. All right, what does x equal now? Sorry, got to put x up there. What does x equal now? 45. Two angles are congruent, and they add up to 90 degrees. What do they got to be? 45 and 45. Okay? Questions? All right, we got a couple more. Ben, read out the next one for me. Nice and loud. 4.10.
If a transversal is
perpendicular to one of the two parallel lines.
All right, stop right there. So we got parallel lines, right? We do the little dart. That tells us parallel. Okay, how do I draw my transversal? How do I draw a transversal to parallel lines?
It cuts it in
It
half.
cuts it, right? It says something about them being perpendicular, so I'm going to go ahead and cut it straight up and down. Okay, read the hypothesis again for me, Ben.
If a transversal is perpendicular to one of two parallel lines.
Stop right there. If it's perpendicular to one of them, if it's perpendicular to one pair of two parallel lines, then what is the conclusion?
Then it is perpendicular to the others.
Then it's so if I put an X right there, and this is a problem in your homework, what is X going to be equal to?
What's X?
90 degrees. It's kind of hard to see. My pen ran out for some reason. This would have to be 90 degrees. So everybody's eyes up here. If that, right, if a transversal's perpendicular to one parallel line, then it has to be perpendicular to the other parallel line. All right? What about this one? Do you know X on this one? Why?
Because it's still parallel.
Because it's still parallel, you know that it equals 90 degrees. How about this one down here?
90.
Careful. What is X now?
Not 90 degrees.
If you don't know that it's parallel, if I don't put that dart there, then you can't assume that that one's 90 degrees. Okay? The only way you get to say 90 degrees is if you see parallel. Okay? Questions? Any questions on that? All right, read the last one for me, Chester.
In a plane, if two lines are perpendicular to the same line,
All right, stop right there. In a plane, what does that mean? That's geometry talk for what? On your paper, on your desk, on the whiteboard, on the smartboard, on a flat surface. Okay, read it again. If, in a plane, if,
two lines are perpendicular to the same line.
all right, two lines are perpendicular. So if this, right, here's your transversal, here's R and S, okay, if T is perpendicular to R and S, if, then what is your conclusion about those two lines?
They're parallel.
Then they are parallel. Parallel here, parallel here. Okay, so if this, right, perpendicular, then you can say parallel. Okay, questions? All right, what about now? Here's L. Can I say that L is parallel? No, why not? Can I say that L is parallel now?
Yes.
All right, here's a question. What if I draw X, line X over here? Is X and T parallel?
Yes, I don't know.
Could X be drawn like this? Or like this? Sure, you can't assume that it's parallel. Do you know that it's parallel now?
Yes.
Yes, you do, by that theorem. Why? Because now R is the transversal. R is the transversal on X and T, and it's perpendicular to both. If R is perpendicular to two different lines, then that line and that line have to be parallel. Bella?
The last line where it says L, like the box, does that mean it's going to be parallel because it says 90 degrees?
If this is 90 degrees, then L is parallel to R and S. Let's draw another one. If I do this and there's no box, then it's not parallel. If I add the box, then yes, it is parallel.
Even if it doesn't have any dot.
Well, if I say this, then I know this. Okay, good question. It's kind of hard because once I draw it up there, then it's up there forever. You see what I'm saying? Yes.
So either there's a box there or it's going to have a little like arrows for you to know.
Well, it's going to ask you, it's just going to have some problems up there, and it's going to say, is R parallel to S? Or is S parallel to L? And you have to look for the box. Or it might have the boxes, and you have to look, you might have to look for the dart.
Do you have to have both or can you have one or the other?
One or the other.
Okay.
One or the other. If it's got the darts, you know they're parallel. If it's got the box, then you know it's parallel. All right, let's practice. I think you'll get a little better with practice. Turn in your workbook, and let's do a few problems in your workbook. Somebody tell me what page.
The green.